Hello everyone, and welcome to this video on recurrence relation. So in this video we want to solve the following recurrence relation, and I have that recurrence relation in green, in the green rectangle, and it states that t of n is equal to t of n minus 1 plus 4, and the base case states that when our input n is equal to 1, our function t is also equal to 1, and of course the base case being right there. Alright. So let's go ahead and get started. So the first thing that I'm going to do is create two different columns. So one column I'm going to call K, and this column will hold the number of iterations that we go through to solve this problem. And then I'm going to have another column called T of n, and this column will hold the function, the recurrence function, at that current iteration. Alright, so it's going to show us what that function looks like. Alright, so let's go ahead and get started. So for our first iteration, we're going to set k equal to 1. And then all we're going to do is rewrite our recurrence relation. So that's t of n is equal to t of n minus 1 plus 4. Okay? Alright, so to go to the next iteration, we need to know what t of n minus 1 is. Alright, and that's simple enough. We can figure that out just by plugging in n minus 1 into our original equation or function. Okay, so I'm going to write it in blue here. I'm going to put t of n minus 1 is equal to t of n minus 1 minus 1. And again, all I did was plug in n minus 1 for n into our original function. And then plus 4. All right, so let's just simplify this a little bit. So this is equal to t of n minus 2 plus 4. All right, so that's what t of n minus 1 is equal to, which is t of n minus 2 plus 4. All right, so now we can go to our second iteration, k. So we're going to set k equal to 2, and now our function t of n looks like this. So t of n is equal to, well, before we had t of n minus 1, this time we're going to replace it with, and let me just use red here, we're going to replace it with t of n minus 2 plus 4, and then we need to add that other 4 from here. Okay, so let's just add 4. And now what does this equal? Well, this is equal to t of n minus 2 plus 2 times 4. All right, so to go to our next iteration, we need to know what is t of n minus 2. And we're basically going to continue doing this until we see a pattern to come up with a general form. All right, so I don't see a pattern yet. So let's just go ahead and figure out what t of n minus 2 is equal to. And we can do the same thing like we did before for the function t of n minus 1. But this time, since we're doing it for the function t of n minus 2, we need to plug in n minus 2 into our original equation or function instead of n minus 1, right? So all we're going to do is plug in n minus 2 into our original function. So let's go ahead and do that. So we get t of n minus 2 minus 1 plus 4. And I'm going to simplify this. So we get t of n minus 3 plus 4. All right. So now we will set our k value equal to 3 for our third iteration, And now we will rewrite T of n. So T of n is equal to, and I'm going to use red here, is equal to T of n minus 3 plus 4. And then we need to add in this 2 times 1, or 2 times 4 there. All right, so I'm just going to add 2 times 4, and then I'm going to simplify this. So we're going to get T of n minus 3 plus 3 times 4. Okay, and I do actually see a pattern already. But if you don't, I'm going to do one more step for you. So we need to figure out what T of n minus 3 is. Okay, so this is equal to T of n minus 3 minus 1 plus 4. And then this is equal to T of n minus 4 plus 4. And then now for our fourth iteration, T of n is equal to T of n minus 4 plus 4 plus 3 times 4. And this is equal to T of n minus 4 plus 4 times 4. All right. So now, if you don't see the pattern, I'm going to rewrite our first equation here at the very, very top. And this is equal to T of n minus 1 plus 1 times 4. All right. So now we can see these functions here, and I can see the pattern quite clearly. Okay, so now I know that the general form, so I'm going to put a few dots here, for some value k, the general form is, or some iteration value k, the general form is T of n is equal to T of n minus k plus k times 4. All right, so that's our general form. So I'm just gonna, put this in its own little rectangle because it is important. Now we want to know, well, when will this recurrence relation stop? And of course, we know that it's going to stop when it hits its base case. And where's the base case? Where the base case is right there at the very top inside the green rectangle. And the base case states that when the input is 1, so that's our input 1 there, then the function t, and this is the function t, right? Then the function t is equal to 1. All right, so all we have to do is make the input for t equal to 1. So the input is right there, right? And so our input is n minus k. So we need to set n minus k equal to 1. All right. So that just means that n is equal to 1 plus k, and n minus 1 is equal to k. All right. So now what this means is, this means that we can plug in n minus 1 for anywhere we see the value or variable k. All right. So we can do that to our general We can plug that value into our general equation, and that will help us solve this recurrence relation. So let's go ahead and do that. I'm going to just kind of mark a little area for us to finish. All right. And what we're going to do is we're going to first rewrite the equation. So T of n is equal to T of n minus k plus k times 4. All right, now I'm going to plug in n minus 1 for k. So T of n is equal to T of n minus n minus 1. And I hope I said that right before. I'm going to plug in n minus 1 for k. All right, so plus n minus 1 times 4. Okay, now we get T of n is equal to T of 1 plus 4n minus 4. Okay, and according to our base case, T of 1 is equal to 1. So we're going to write this again. We get T of n is equal to 1 plus 4 times n minus 4. And now we get T of n is equal to 4n minus 3. And that, my friends, is the answer. So I hope you really enjoyed this video, and I hope this was very informative to you and helpful. And if you like it, please leave a like on the video. Please leave some comments in the comment section. And thanks for watching, and I will see you all in the next video. See ya.